Hello everybody, this is a presentation on sketching exponential graphs, and it's mainly from exercise 5a in your textbook. So the question is, if we had to sketch y equals 2 to the x minus 2 minus another 2, what would the graph look like? Now, usually when you're sketching graphs, I'd sort of insist that you adopt a certain standard. So I'd like you to find all the intercepts, I'd like you to sketch the asymptotes, and I'd like you to label the asymptotes with their equation, and I'd like you to label the intercepts with ordered points. So let's see if we can do those things. So x-intercept, y equals 0, y-intercept, x equals 0, and let's do some asymptotes over here. And we'll do the domain and range down the bottom here, and I'll sketch it up the page. So if y is equal to 0, that would be 0 is equal to 2, x to the minus 2, minus 2. Now I'll take that 2 across to the other side, which means I'll end up with 2 is equal to 2 to the x minus 2. Now this 2 is to the power 1, so that means I'll have 1 is equal to x minus 2. Since that power must be equal to that power, since the bases are equal to each other, then the powers must be equal to one another. And if I take that 2 across to the other side, I'll get x is equal to 3. So we'll have an x-intercept of 3, 0. When x is equal to 3, y is equal to 0. Now what about if we put x is equal to 0? So y is equal to 2, now x is equal to 0, so that would be 2 to the minus 2 minus another 2. Now 2 to the minus 2 would be 1 over 2 squared, and 2 squared is 4, so this is 1/4 minus 2, which is negative 1 3/4. So our point would be 0, negative 1 3/4. Now the asymptotes, now let's see. With an exponential graph, usually the graph goes something like this, with a asymptote of y equals 0 and going up like this. With this minus 2, everything's been dragged down 2 units, so the asymptote would be at minus 2. Now that would mean that the domains could be any real number, so we could put in any x value we liked and that would be fine. Now the range, well, since the graph must be above y equals minus 2, but since that's an asymptote, we can't include negative 2, so we'll go from negative 2 up to infinity. Alrighty, give me a second and we'll plot it all together. Now it is important when you sketch these graphs, you use the scale that's given to you on the exam or on any SAC or any other assessment task. So we had an asymptote at y equals minus 2, so I've used the minus 2 on the scale there and labelled the asymptote y equals minus 2. There is an intercept at 3, 0, and I labelled that with an ordered point, and there's another intercept down here at 0, negative 1 3/4. Now our graph will go up like this and through that point and off to infinity. And that's what it should look like. Let's try another one. Alright, so if we have this, what we want to do is to figure out the x-intercept, the y-intercept, the asymptotes, and the domain and range. Now, as we did before, for the x-intercept, y is equal to 0, and for the y-intercept, x equals 0. And for the asymptote, well, since it's moved up 9, that'd be an asymptote would be at 9. Now, usually for an exponential graph, the graph would go something like this. But with a negative in front here, it'll be reflected down like this. So our graph will be down below the asymptote. So the domain and range would be, well, the domain would be all real numbers, and the range, well, since our graph has moved up 9 and it's a negative exponential like this here, it would be from negative infinity up to 9, but not including 9, round brackets, and it's that way because it goes up towards this asymptote at y equals 9, but it never reaches it. Give me a second and I'll work out the x and y intercepts. Okay, I wanted to move a bit quickly there. So if y is equal to 0 and I substitute it in 0, I can take this across to the other side and get rid of that negative. Then I'll change that 9 into 3 squared because 3 squared is equal to 9. Now if the bases are equal to one another, the powers must be equal. So minus 2 is equal to x, which means x would be equal to minus 2. Now if I substituted in x equals 0, this would be 3 to the 0. 3 to the 0 is 1. Now minus 1 plus 9 is 8, so the other intercept would be 8. Alrighty, let's see if we can sketch this now. Alrighty, if we're sketching it now, there'll be an asymptote up here at y equals 9. Now our graph will come down, it'll go through 0, 8, and also go through at 2, 0. So our graph will come down like this and go like this. Alrighty, one last one and then we'll be done with this presentation. Now this one I only mean to be very brief. Now what I'll do with this 1/3 is change this. 1/3 is the same thing as 3 to the negative 1. Now negative 1 times x is negative x. Now this is one very similar that we did before. When the x is negative, it's reflected in the y-axis. So our graph would be, now let's see, with a plus 3 means the axis or the asymptote is up at y equals 3. Now because the x is negative instead of positive, that means it's been reflected in the y-axis. Now usually we would expect an exponential graph to go up like this, but because it's been reflected, it'll do the opposite. So our graph would go something like this. Now let's see, we wouldn't have an x-intercept, we'd only have a y-intercept. So our y-intercept would happen when x is equal to 0. So if that was the case, y is equal to 3, and in place of x goes 0. 3 to the 0 is 1, 1 plus 3 is 4. 0, 4, that would be our intercept, 0, 4. Alrighty, so that ends our presentation. I hope that helped. Remember, this was all related to exercise 5a. Go through that, see how you go, and ask me any questions if you need to. I'll see you in class.